Section 2 in science class today is titled Why Do Objects Float? As we continue our study of fluids. The first thing that we're going to discuss and look at today is that of the buoyant force. Why do objects float? Because there's this force that exists that pushes on things that allows them to stay at the surface of the type of fluid that they are in. As you begin your reading, you'll see that the buoyant force is described as an upward force that balances out Earth's gravity that's pulling you downward. So as Earth's gravity is pulling downward, buoyant force is what pushes you up, balancing your weight, which allows you to float. Well, this force is called the buoyant force. It's an upward force that exerted by a fluid or an object in the fluid. Now, what causes this buoyant force? The buoyant force is caused by the pressure that is exerted by a fluid or an object in the fluid. This figure shows a cube-shaped object submerged in a glass of water. You'll notice that the buoyant force acts on all the different surfaces on that cube, rather than just on the bottom. One of the reasons why objects float is because they're on the surface of the water and that buoyant force acts on the bottom. But as that object is submerged inside the liquid, this force exerting pressure on all the different sides of the cube. There's a greater pressure at the bottom because it's deeper, which often results in that upward force being greater than this downward force. But the buoyant force acts on all the different surfaces of that object when it's submerged in the water. The water exerts a pressure everywhere over the surface of the object. The bottom of the cube is deeper in the water, therefore the pressure that is exerted by the water at the bottom of the cube is greater than it is at the top of the cube, allowing it to be pushed up and a lot of times kept at that floating position. The force that is exerted on the cube due to water pressure is not balanced, and a net upward force is acting on the cube due to the pressure of the water. So, because there are objects in the water that can be deeper than others, the overall force between what's being pushed down and what's pushing up is not balanced, so it doesn't just stay kind of in that floating position. It's actually pushing upward to remain at the top or the surface of the water. This upward force is the buoyant force. The buoyant force pushes an object in a fluid upward, but gravity pulls the object downward. If the weight of the object is greater than the buoyant force, the net force on the object is downward and it sinks. So what causes something to sink? If it's got a greater force pulling it down than it does pushing it up, it sinks. If the buoyant force is equal to the object's weight, the forces are balanced and the object floats. So if the pressure pushing up on the object equals what's pushing down on it, it will always float. Changing the buoyant force. Here you're reading on page 350. Whether an object sinks or floats depends on whether the buoyant force is smaller than its weight. The weight of an object depends only on the object's mass, which is the amount of matter the object contains. The weight does not change if the shape of the object changes. The buoyant force does depend on the shape of the object. The fluid exerts upward pressure on the entire lower surface of the object that is in contact with the fluid. If you take a look at the picture on the top of page 350, there's a piece of foil that's folded up that has a really small surface area. It's placed in this water, and you can see that, guess what? It has sunk down to the bottom of that water. Now, the buoyant force is less than the foil's weight, it sinks. But in this example, you got the same size piece of foil, but not folded, it's unfolded, and it lays in this flat type of shape. Its surface area is much larger, therefore it takes a greater force to pull it down even though it has the same exact weight. The buoyant force then pushing up on it has a larger area to push on, which then creates buoyant force equal to its weight, and the object floats. Both the same material, but one in a different shape, allows it to float. If this surface is made larger, then the more upward pressure exerted on the object and the buoyant force is greater. So if there's a bigger surface area on the bottom, something will get pushed up on greater and will have a better chance to float. Suppose you drop a steel cube into the ocean. You might think that the cube would sink only to a depth where the buoyant force on the cube balances its weight, but that's not true. However, the steel sinks to the bottom no matter how deep the ocean is. Eventually, as it goes down into the water, it doesn't have a point of like equilibrium where the force going downward equals the buoyant force. It will just constantly keep sinking until it gets to the bottom. The buoyant force in the cube is the difference between the downward force due to the water pressure on the top of the cube and the upward force due to the water pressure on the bottom of the cube. So it's going to continue to sink because that buoyant force is not overcoming that force that's pushing down. When the cube is deeper, the pressure on the top of the surface increases, but the pressure on the bottom surface also increases by the same amount. So even though there's a difference between what's pushing down here and what's pushing up here, that changes variably as the object continues to sink. As a result, the difference between the forces on the top and the bottom is always the same. There's a ratio between those. No matter how deep the cube is, it's submerged and it's going to continue to sink. Archimedes' principle on page 351. According to Archimedes' principle, the buoyant force of an object is equal to the weight of the fluid it displaces. Think about what happens if you drop an ice cube in a glass of water that's filled to the top. The ice cube takes the place of some of the water and causes the water to overflow. According to Archimedes' principle, the weight of the overflow or displaced water would be equal to the buoyant force on the ice cube. As you put something in water, the object that takes the place of that water is equal to the amount of water that's displaced. So the weight of that object is equal to the amount of water that is moved out of that object. How do we tell that? Well, density tells us that. The density of a fluid or an object is the mass of the object divided by the volume it occupies. So it's calculating how much mass there is in the size of the object, how much material there is, how much matter there is, and how much space that the object takes up. Density can be calculated by the following formula. Density equals mass divided by volume. Mass is often measured in grams, where volume is in cubic centimeters or in liters. The mass of any volume of a substance can be calculated by multiplying both sides of the above equation by volume. This gives the equation mass equals density times volume. So if you rearrange the equation to solve for mass, mass equals density times volume, in which the density is going to cancel out with volume to give you just the mass unit as your answer. Then if the density and volume are known, the mass of the material can be calculated. So if you know density and volume, you're using this equation. If you know mass and volume, you're using this equation. Sinking and density on page 353. Any material with a density that is greater than the density of water will weigh more than the water that it displaces, and it will sink. So if it's got a greater density than the fluid that it's in, it sinks. If it's got a lesser density than the fluid that it's in, it will float. This is true for any object and any fluid. Any object that has a density greater than the density of the fluid it is placed in will sink. Suppose you place a block of wood with a volume of 1,000 cubic centimeters into a container of water. This block weighs about 7 newtons. The block starts to sink and displaces water. However, it stops sinking and floats before it becomes completely submerged. Any object with a density that's less than the fluid it is placed in will float. So think of the objects that you know that sink and that you know that float. So throw a rock into a body of water, a river, lake, whatever it is. The rock has a large density compared to water, as in it's heavier in the same amount of size, it's going to obviously sink. If you want to float, think about the things that we use to float when you're swimming at a pool. You might use some type of air tube or floaty or life vest that's filled with material that has air inside of it, because air is less dense than water. Anything that has air going into the water is actually going to float up on top of the surface. On the next page, we learn how boats use this same principle to float. Archimedes' principle provides another way to understand why boats that are made of metal can float. According to Archimedes' principle, increasing the weight of the water that is displaced increases the buoyant force. By making the volume of a boat large enough, enough water can be displaced so that the buoyant force is greater than the weight of the steel. So you're probably thinking to yourself, Mr. Shane, you said that if the object is more dense than the actual fluid that it's in, it'll sink, and boats are made out of metal. How can boats float? Well, when you're thinking about how a boat floats, you have to think about all the space that the bottom of the boat, the hull of the boat, takes up. It actually moves all that water out of the way. The weight of that water then provides the force that pushes back up on the boat, because all the space inside of here is, guess what, made out of air. So the space here is made out of air, which is less dense than the metal and less dense than the water, and it actually equals the amount of weight that's taken up by the water that's moved out of the way or displaced. So if that water that's displaced is greater than the force that's pushing down, the force pushing up therefore is greater. Even though the boat and the cube have the same mass, the boat displaces more water because of its shape. So they're saying that here's a boat made out of metal, here's a cube made out of metal. Depending on the shape of that object depends if it's going to float. If you look back and remember the picture we had of the two pieces of foil, the one that was crumpled up or folded up sank. The one that had the larger surface area that displaced more water allowed it to float. So therefore the boat floats, but the cube sinks because all of this extra space here, and then what's inside there? There's obviously air inside there that moves all that stuff out of the way. A couple questions to review. What is the name for the upward force that is exerted by a fluid on any object? That would be the buoyant force. Explain why the buoyant force is an upward pointing force. Well, as pressure increases with depth, therefore the bottom of any object liquid has a greater force acting on it than the top does. For example, if you're standing in water, your feet have a pressure pushing on them greater than the pressure that's on your shoulders at the top of the water. So that upward force is this difference in pressure that's applied by the depth of the fluid. Explain why the buoyant force on an object is the same regardless of its depth. Well, the buoyant force on the top of an object increases with depth, but the buoyant force on the bottom also increases by the same amount. Therefore, the difference between those is always going to remain the same no matter what depth the object is. The buoyant force on it is equivalent to that experienced at any other depth. That wraps up our study of what would be Chapter 12, Lesson 2. Use our notes today and your own reading to complete the reinforcement. God's blessings.